Today we're doing section 2.1, day 3, still talking about complex numbers, and today we're going to kind of just do various examples that are dealing with i's. So a recall on the quadratic formula. Quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And remember that you use quadratic formula when you have a quadratic equation that is written in standard form and it has to be equal to 0 in order to use the quadratic formula. So for our first example, we're in standard form. It's set equal to 0, so we're good to go on identifying a, b, and c. So we can go ahead and plug into the equation. So it's x equals negative b. And obviously, if you recognize you have the double negative, you can just write it as a positive. I'm just showing all my steps. Plus or minus the square root of b squared minus 4 times a times c all over 2a. And whenever I teach this to students, I always kind of tell them to focus on the part underneath the square root first. So negative 2 squared will be 4. Then I have 4 times 3 times 4, which will be minus 48, which will be a negative 44. And it's underneath the square root, so I can say this will be negative 4 and 11. So this part will break down to be 2i root 11. And now that I know that part, I'm going to bring it back into the problem. So I have x equals 2 plus or minus 2i root 11 all over 6. Because the 3 outside values can all be reduced, I do expect you to reduce. So it'll become 1 plus or minus I root 11 all over 3. And again, I went through that relatively quickly because this is a review of Algebra 2 material. All right, next example. So now, still dealing with quadratics, but we're not asking you to solve, we're asking you to evaluate, which means plug in. So we're plugging in 1 plus I squared minus 2 times the quantity of 1 plus I plus 2. So I'm going to write this twice. So I have 1 plus I and a 1 plus I. Distribute over here, so I'll have negative 2 minus 2i, and that plus 2 is still hanging out on the end. So I'm going to FOIL. Again, if you do the box, go ahead and do the box and put the terms on the outside. When we FOIL, I have 1 plus I plus I plus I squared. Those 2's are going to cancel, so I still have this minus 2i. Let's see, I know this is negative 1, so the 1 and the negative 1 are canceling. And then I have positive 2i from adding these, minus 2i. They're going to cancel, and the answer is going to be 0. All right, last one. We are asked to simplify, so what we could do is change this 1 to be 1 over 1. And then I'm going to multiply top and bottom by I to get common denominators. So I have 8 all over I plus 2 over I. And again, we know the whole point of getting common denominators is to put this together. So I have I plus 2 all over I. We're going to keep change flip. So 8 times I over I plus 2 will become 8i over I plus 2. And I'm actually going to rewrite this as 2 plus I because that's just what we're kind of used to. Oop, I hooked that. 2 plus I. All right, so I plus 2 is the same as 2 plus I. Now that I'm there, I need to go further because you can't leave an I in the denominator. So I'm going to have to multiply by the conjugate. I'm going to switch screens so I have more room. All right, so to multiply by the conjugate, we're going to multiply by 2 minus I top and bottom because I need to get that I out of the denominator. So in the numerator, I'll have 16I minus 8I squared. Denominator, I'll have 4. I know the inner and outer are going to cancel, so minus I squared. In the numerator, I'll change that I squared to be -1. So that's going to become a positive 8 plus 16I, because you got to put it in standard form, over 5. Nothing can reduce, so this is as far as I can go. So I've completely simplified the problem. So one last application, and that would be letter C. So it gives you the equation E equals IR. E is voltage of a circuit measured in volts. I is a current measured in amperes. I'm not sure how to say that. R is resistance, ohms, and they give you, they want you to find the voltage E if I equals 4 minus 5I and R equals 3 plus 7I. So this is relatively easy. I just have to plug it into the formula. So I have 4 minus 5I for I, and I have 3 plus 7I for R. And you just have to FOIL to solve this. So I'll have 12 plus 4I minus 15I minus 5I squared. That'll combine. This is a -1, so -5 times -1 is +5, plus the 12 would be 17, and this will leave me with -11I. So I just realized I messed up. It would help if you copied the problem, right? So this should be a 7 here. So let's see, the 12 is going to be fine, and the 15 is going to be fine. This is a 28, and this is going to be 35. So bear with me. Quick little fix here. So this will become positive 35 plus 12, which will be 47. Then I have 28 minus 15, which will leave me with 13I. And because E is measured in voltage, the units of this would be a volts. All right, that's all for today. I'm sorry I made a little mistake. I'm glad I caught it in time now.